Hello everyone. Today we are diving into the world of large language models and one of the most important mechanisms behind them, that is the attention mechanism. If you have ever wondered how ChatGPT or BERT work, this is the perfect video for you. It all happened in 2017 when a groundbreaking paper called as Attention is All You Need introduced a revolutionary concept which is called as the attention mechanism. This attention mechanism is the heart of all the large language models currently used. This particular paper also introduced a neural network architecture which is called as the transformer. Now, what's so special about this transformer? Well, unlike older models, it can be trained in parallel, which speeds up entire training process. This was a true game changer in machine learning. Now, let's look at the overview of transformer architecture. I will simplify it for you. This transformer architecture is mainly made up of two parts. As we can see in this diagram, there is encoder block and there is decoder block. These are the two main components. The encoder processes the input and understands it, whereas the decoder generates the output based on what the encoder understood. The output of encoder block becomes input to a decoder block. These two parts of the transformer work together in a loop, but they are stacked on top of each other in the transformer, as we can see here. Think of it like a team where one person, which is called as encoder, reads and understands the text, and the other person, that is a decoder, generates the response. The transformer is autoregressive in nature. Here autoregressive means that this transformer generates one word at a time, but in order to generate the new word, it takes input all the previously generated words. This is like building a sentence one word at a time. Now that we have seen the overview of transformer architecture, let's study encoder block and then let's study decoder block. So let's zoom into the encoder architecture. This encoder block has two main parts, the self-attention mechanism and feed-forward neural network layer. The self-attention layer, it helps the model focus on different part of the input sequence. It also helps the model understand how words relate to each other. The feed-forward neural network, it processes the information from self-attention layer. Now this particular self-attention layer allows the encoder to look at different positions within the input text, making it easier to represent the input meaningfully. This helps to create something called as contextualized word embeddings, which means that each word is represented based on the words surrounding it. Now let's zoom in to the decoder part. The decoder also has self-attention, but it is a bit different. It uses masked self-attention. But why? To make sure that decoder does not cheat by looking at the future word while it is generating the current word. It only focuses on the words that have been already previously generated. In addition, the decoder also has encoder attention. This component looks back at the encoder's output to ensure that the decoder is generating the right response based on the input. Together, this encoder and decoder create the transformer architecture, which powers powerful models like BERT and ChatGPT. Now, you might be wondering, can we only have model with just the encoder or just the decoder block? Now that is a great question. The original transformer architecture works best for tasks like machine translation, where both encoder and decoder block are needed. However, when it comes to tasks like text classification, we don't need the decoder part, we only need encoder only. This is where encoder only models come into play. The classic example of encoder model is BERT. BERT is all about understanding language, not generating it. It's designed to create amazing representations of language that can be used in different or variety of tasks. Now let's talk quickly about BERT. BERT is a model that uses only the encoder part of the transformer. It means that it focuses on understanding the input text rather than generating an output. The CLS token is added at the start of the input sequence or start of the input. This token is special because it represents the entire input sequence. For many tasks, the embedding of this token is used to make predictions. BERT also uses something called as MLM or masked language modeling. Here, some of the words in the input are randomly hidden or masked, and BERT tries to predict them. This helps BERT to learn deep contextualized language representations. Once BERT is pre-trained, it can be fine-tuned for specific tasks like text classification, NER, and so on. Now, this pre-training saves a lot of time because the model already knows so much about a particular language. On the flip side, there are decoder-only models like GPT. These are called as generative models, which means that they are designed to generate text, not just understand it. GPT uses the decoder part of the transformer, but with masked self-attention. But why? It is to predict the next word based on the previous ones, just like we as humans complete a particular sentence. A key feature of generative model is something called as a context window or context length. This defines how much text the model can consider at once. Models with larger context window can handle longer documents. As new words are generated, the context window grows as well. Now let's recap everything what we have learned today. First, we saw encoder-only models like BERT, which focus on creating representations of language, and it is perfect for tasks like text classification. Then we saw decoder-only models like GPT, which are great for generating text and answering questions. Both the type of models are incredibly powerful in their own ways and are used in variety of applications. And it all starts with this transformer architecture. Thanks a lot guys for watching this particular video. I hope now you all have a clearer understanding of transformer architecture and how it powers some of the powerful language models which are available today. Stay tuned for more videos where we will dive deeper into the architecture of attention mechanism and other cool concepts surrounding LLMs. Don't forget to like this video, subscribe to the channel and leave any questions or doubt in the comment section. I will reply to that. Thank you everyone.